The displacement time graph below shows the motion of a single part of a rope, point P, as a wave passes by, travelling to the right. Use the graph to find the amplitude, period, and frequency of the wave. Okay, so when we have a displacement time graph, we are looking at a single point and how that single point moves, over time. So if we have a little point here, and we imagine that a wave is coming past like that, this point is going to go up, then back down, then back up, then back down, and so on. So it's going to follow the path of this graph. Okay, so we're just looking at an individual point here. So let's have a look. What do we want? Amplitude. Okay, so remember, amplitude is our maximum peak height from the origin. So our amplitude, we can read off the graph, is 0.5 meters. Okay, period. So period is the amount of time it takes for one full wave. So remember, on a displacement time graph, the x-axis is time, and so the points between here and here have to be a time. So that's how you know that is your period. Oh, I used the wrong symbol there. That's how we know that's the period. In a displacement distance graph, our x-axis is distance. So that, from peak to peak, that must be a distance. So it's wavelength. Okay, so our period is measured in seconds. So by looking at the x-axis, time in seconds, we can see that this is meant to be period. If we had a distance down the bottom, we know that wavelength is measured in distance, so we'd be looking for wavelength. Okay, but they're basically the same measurement in terms of what we see on a graph. So our period in this case is the amount of time for one full wave. So we can see it is 2 seconds from our graph. Now, from that formula on the previous slide, frequency is equal to 1 over the period. So 1 over 2, so our frequency is 0.5 hertz.